Okay, this is chapter 4 that I wanted to get into right now. And this is something that I may have neglected to get after, and I think a lot of our projects out of chapter 3 and 4 kind of suffered because I didn't maybe go through this well enough. I remember that the author did not assign any projects out of chapter 4, but the principles were used in the section following. So I kind of like apologize for not getting after this a little better. So what geometric construction are little tools that you should have in your drafting toolbox to solve geometric issues that you can't use if you that you couldn't use if you didn't have a protractor. If you had a protractor, then you can kind of work your way around some of these issues. But knowing some of the tricks and techniques kind of helps out. So if we take a look here, we're going to take a look at the identify the geometry that makes up basic 2D drawings, and then use board drafting or 2D CAD skills to create technical figures. We're going to describe the advantages of CAD contrasted with drawing with manual instruments. Okay, so let's take a look at our basic geometry review here. Now we have triangles, quadrangles. Okay, we have polygons, which are many sides, circles, and then we have arcs as well. Okay, triangles, remember the basics of triangles, the base and the two sides. In a rhomboid here, we have two parallel lines opposite each other. In a trapezoid, we have two parallel lines, but these two on the side don't have to be parallel. Then we have the standard, six-sided heptagon and an octagon. Then we have the hexagon, which is 6 sides. Okay, so here we have the exercise of how to create, how to bisect either angles or lines. Okay, so the first way we can do that is using two 45-degree triangles, and then we just shoot up these projections, and wherever they intersect, if we drop a perpendicular line down, that line will be bisected, and coincidentally, so will the angle. So the angle and the line will be bisected. All right, now, very similar to this is the method with the compass. So what we would do is set ourselves up on, say, A and B, and then take a compass measurement a little longer than half, and then swing an arc. Swing one that way, swing one this way, that way, this way. And then if we connect the line, that line bisects those 2 points right there. Okay, here we go, bisecting the line with a triangle and a T-square. Same kind of thing, the two 45 degrees intersect up in here, drop that line down, and that line is bisected. Similar thing if the line was vertical. Okay, we have two types of triangles that we work with. Unfortunately, you only received the adjustable 45-degree triangle, but we've ordered some of these 30-degree triangles that we share with another class. So when we get into isometric drawings, I'm going to go ahead and pass these out while you're in class, but I'll collect them later because, again, we share these with two classes. So you notice here that we have these 45-degree triangles, and 45 degrees is half a 90, so that by definition, this bisects that 90-degree angle. Whereas the 30, 60, 90 triangle divvies everything up into 30-degree increments. Okay. And here, this is kind of an important sheet. So I would say label this here so that you could come back and refer to how to make different type of angles exclusively with your T-square and with a combination of the 30, 60, 90 triangle with the 45-degree triangle. And most notably, say the 75 degrees here. So you would lay a 30-degree triangle here with a 45-degree. So that would be 30 plus 45. That would be 75 degrees. In this case, you are taking the 30-degree triangle and subtracting out 45. So that would give you a 15-degree triangle. I'm sorry, take that back. 15 degrees and subtracting out 30 degrees would leave you with 15. Okay? And then you can kind of work your way around there. So it's a handy way to remember how to create different angles just with two triangles. Okay? Or you can do it using your protractor. Or on professional drafting machines, the manual drafting machines, they had these angular measures here that we used to use. Okay? and bisecting angles, very similar to what we did with the two sides. Here with this angle, he strikes an arc, and then he has the 2 points that he establishes by creating the arc. He then swings 2 other arcs, a little longer than the halfway of this this particular arc, or actually halfway longer than a little longer than the chord length here, and that's where that intersection would be. And then he just bisects that. Okay, so what I taught you guys to do is just to draw a line straight across. Okay, and as long as the line was equidistant from A to E and A to F, as long as those were the same, then this whole system would work. But this is probably the surefire where he's creating an arc there. Okay, so if you want to transfer an angle, what he does is, this is a new line that's going to create the new baseline of AB. So this system here is going to be rotated and then laid down this way. So what they do is they go ahead and strike an arc, okay, and you have the 2 points here. Then you come back and you establish yourself on the B point and strike an arc up this way on your known. Okay, then you come back to this system, establish yourself on the new E prime, and then swing up this way, and wherever those 2 lines intersect is where the line, this new line, should be. So thus you're duplicating that system but rotating it down. Okay, this should be pretty fundamental. If I have either a triangle or a T-square, I can lay either one of these angles down. Just depends on how you lay it down here, but you want to lay one side down parallel to the line. You can then slide this up and create another parallel line. Okay, or you can establish yourself, take a radius and then just swing an arc anywhere else, and wherever you touch both the tangent points of the arc is parallel to this. Okay, and the same way here, where you say have A to start off with and you have a radius, you can just swing, and this swinging will create a bunch of little tangent points, and you can take your flexible curve and then just kind of kiss those tangent points, and that should replicate this this arc. Okay, drawing lines through a point and perpendicular to a line. Okay, in the case where you don't have, let's see, when a point is not on a line and you have a situation where you know what A and B is and you know what point P is. Okay, so what you want to do is somewhere conveniently you want to draw a line between P and D. Okay, and you then want to bisect that line, and you know how to bisect that line, so we find the middle of that. Okay, so then we establish a center of an arc here at C with this as the end of the radial point. Okay, so it's a radius of this. You swing that around, and by definition, wherever it intersects, wherever this arc intersects A and B, is what should be perpendicular to between A and B and P and E. So this should be perpendicular. And what tells us that is that you have this length and you have these 2 sides are equal. Okay, that would make that, if these 2 sides are equal, that by definition this is 45 degrees. Okay, so let's take a look at a point out here if it's not on the line. So if we have a point out here in space that's off this line, what we can do is set up our radius here and make sure that the compass is set to over this length right there, just kind of over here somewhere. You can take an arc and then swing, and then you give you points C and D. From C and D, you can create an arc that creates a point E. Okay, and that line should be perpendicular because you're bisecting that line again, so there to there. Okay, again, here if you have a point along that's on the line, all you need to do is set up your compass here, swing an arc, swing an arc. Okay, that'll give you 2 points equidistant. Then you open up your compass again, swing an arc here, swing an arc there, gives you point F. That point is perpendicular, and through that point as well. Okay, so in this case right here, where we have this triangle, this is a very special triangle. I want you guys to memorize how to create this. Okay, so you're given A and B. Okay, and you first of all divvy in Convenient units, the bottom, base. So 1, 2, 3. Okay. Set yourself up at where you originated at that three-legged side, and swing an arc up here at 4. Okay, so it should give you an arc there. Then wherever you end up at the 3, put your compass there and swing an arc 5 units up. Okay, and wherever that intersects, that will give you the 3, 4, 5 triangle, a very special triangle that's perpendicular at P. Okay. In this section, we're going to lay out triangles with given lengths. Let's say we're given a length of A, a length of B, and a length of C. So what we'll do is we'll start off with C. We'll just go ahead and draw a line down in C. Then we set our compass up to be the length A and swing that arc. And then we'll set up our compass to be length B, position it there, and just swing an arc. And we have this point of intersection. By definition, this is A, and that's B. So we just draw our triangle. Okay, that's kind of fundamental stuff. That's not that big of a deal. Okay, this one down here, if you want to draw a right triangle, only known with the knowns of the R length and the S length, what you do is you lay down the S length, which is point A and B, and you bisect it, and you set up your compass here, and you swing an angle. So once you swing that arc, I should say, not an angle, set up your compass here at the R length, swing another arc, and wherever those two arcs intersect, that's where your right angle will appear. Okay? Okay, I'm going to skip over section 4-11, laying out an angle, okay, with the sines and cosines, or tangents, sines and tangents. I'm just going to go ahead and jump into the draw an equilateral triangle on section 412 on page 133. Okay, so equilateral means equal sides on each angle. Okay, so you have given A and B, and so if I take my arc and swing up, which would give me a duplicate of length A and B, and then I do the same on the other side, so I swing an arc this way, swing an arc this way, that is identical to this length. All these three lengths here are congruent, meaning that they're all the same length. Okay, so if that's the case, if the interior of the triangle is 180 degrees, the sum of the angles, then therefore by definition, then each one of these angles is 60 degrees. Okay, let's take a look at here. If you have a 30, 60, 90 triangle, all you need to do is establish yourself on one of these points, strike a line, and wherever that line intersects is the vertex of that triangle. Okay, now with squares, it's a little easier. Since if you have a 45-degree triangle, you just can lay the triangle here on one of the corners, lay it up, give yourself a side, lay up the other one, and you can lay out this. This is fairly easy. Now, if you have just a compass, remember, here's the key, is that every one of these sides is the same if you're drawing a square. So if you have point A and B, this is given. If you extend out AB, line AB, you can bisect, I guess, this little segment here up to this point. Now, this point here, A, is arbitrary. It could be anywhere. So, but this establishing this arc here first, and then swinging these arcs to find the line perpendicular. You then work your way up at the certain length, AC, and then that's your first, okay, that's your first node. So you've established this line, put your compass here, establish that arc, that gives you these two lines. Then it's just a matter of translating this line up here by, if you have this point, then all you need to do is establish an arc, swing it here, establish an arc there, that's the same length, swing it there, and then you have your square. Okay? And let's see, the regular pentagon. This is kind of interesting. Only one student seemed to have gotten this problem when we did the exercises. So in order to get a pentagon, let's see. Now you can do this by dividers if you happen to know what the particular lengths are. You can just establish yourself at a point and then swing your either compass or your dividers, and you can identify this. By geometric methods, what you can do is is set yourself up here with a coordinate system and then a circle in the coordinate system. And then what you want to do is bisect the segment between O and D. Okay? Gives you the midpoint right there. Then you establish your compass here, establish it from there to the top apex there, and then swing an arc. And once you swing that arc, that'll give you that point right there. Okay? You then take the same radius, or this radius right here. It would be the chord length from here to there. Chord length from this R system, from there to there, and then swing that up. Once you swing that up, that gives you there your first length. From A to B is your first length. Then all you need to do is grab your dividers and go from there to there, from there to there, there to there. Okay, so the key is to bisect this segment. The radius between C and A, swing the arc, gives you E. The radius between E and A, swing that up, gives you point B, which from A to B will give you the first leg of the pentagon.